This is Statistical Analysis of Evanston Spring Break Travels by Natalie Bamanji and Maddie Bear. Our topic. Our topic was to investigate if there was a significant statistical difference in the amount and distance that people traveled over spring break based on if they live in North Evanston or South Evanston. This is interesting because it will tell us a lot about the amount of disparity in income level and level of affluence between the two regions that are both very close in proximity and are considered to be part of the same community and high school. Its relevance is that it could help us determine which region is wealthier and possibly play into a larger study of why certain social groups form and why people decide to live in one of the two regions. It will help us understand which students live in a region where families are generally able to have experiences outside of their hometown more often, and it will be interesting to look into how this fact impacts the individuals in these neighborhoods. Based on our knowledge of which areas in Evanston are generally considered more expensive and safer, and also based on the map that shows which areas in Evanston are eligible for a community block grant, or in other words, are considered in need of improvement, we think that people who live in North Evanston will have traveled significantly further away, and consequently have a higher average round-trip distance over spring break compared to the average round-trip distance traveled over spring break for those who live in South Evanston. This is just the image of the community block grant map. We gathered data from classmates in our biology, statistics, physics, English, and BC calculus classes by having them write down their answers on a piece of paper for us. We asked them to answer two questions. 1, what are your home cross streets? And 2, where did you go for spring break? City and state, country. We then went through each answer and determined whether we considered the cross street to be North Evanston or South Evanston, and we also calculated the round-trip distance in miles from Evanston to wherever they traveled over spring break using Google Maps. If they didn't travel out of Evanston at all, we just recorded that they traveled 0 miles. The data helped us understand and answer our question because it gave us the necessary information to be able to classify our data into two categories by region, north and south, and also gave us the necessary information to be able to calculate an average round-trip distance traveled for each region. This information was crucial because the mean distance traveled, sample size, and region of Evanston allow us to perform a 2-sample t-test and a 2-proportion z-test. These statistical tests will then allow us to determine if there is a statistically significant difference between the two regions' average round-trip travel distance over spring break. For the north side sample, our sample mean was 2,702 miles. Our sample size for the north side was 15 EHS students, and our standard deviation for the north side sample was 2,643 miles. For the sample of south side residents, our sample mean was 1,284 miles. Our sample size for the south side was 17 EHS students, and our standard deviation was 1,738 miles. We graphed a box plot of each sample, north and south side, on Minitab. By comparing the box plots, it is clear that the north side sample has a large mean and median and a larger range than the south side sample. Both samples have outliers, but the north side sample has an extremely large outlier because one of our subjects traveled a round-trip distance of 10,394 miles. The south side sample had a significant outlier as well, but that subject only traveled a round-trip distance of 5,732 miles. These outliers mean that these two subjects deviated from the pattern of our data more than any of our other data points. These outliers points could have the difference between north and south side travel distance seem larger than it is. For this region, we made new box plots and took out the extreme outliers from the north side, 10,394 miles, and from the south side sample, 5,732 miles. Surprisingly, for these new box plots, the distribution for our north side sample still seemed to have a large range and a large mean and median larger mean and median than the south side sample, and there seemed to be an even larger difference in the mean round-trip distance traveled between the two samples in these box plots compared to the original box plots. After looking at the graphs, the first test we performed was a two-sample t-test because we wanted to see if there was a significant evidence that the mean from the north side sample was greater than the mean from the south side sample, or if they were the same. We used the sample sizes and sample means previously mentioned from the two samples, north side residents and south side residents. Our null hypothesis was that the mean round-trip distance traveled is the same for the both regions of Evanston. Our alternative hypothesis was that the mean round-trip distance traveled is larger for the north side residents than it is for the south side residents. We calculated our test statistics to be 1.77 and we found our p-value to be 0.045. We were testing at the 5% significance level, and since the p-value 0.045 is less than 0.05, we reject the null hypothesis. Rejecting the null hypothesis for our study means that we believe there is a statistically significant evidence that says that on average, north side residents traveled a greater round-trip distance over spring break than south side residents. We also performed a two-proportion z-test. For this test, our parameters were the true proportion of north-siders who traveled more than 0 miles round-trip over spring break, and the true proportion of south-siders who traveled more than 0 miles round-trip over spring break. Our null hypothesis was that the true proportion of each region are the same, and our alternative hypothesis was that the true proportion of north-siders who traveled more than 0 miles was greater than that of south-siders. Our sample proportion for the north side was 13/15, and our sample proportion for the south side was 11/17. Our test statistic was 1.432. After performing the test, we found our p-value to be 0.076, which is greater than our alpha of 0.05, so we failed to reject the null hypothesis. This means that there is not strong enough evidence to prove that the true proportion of north-siders who travel more than 0 miles over spring break is greater than that of south-siders. The main conclusions that can be drawn are that while there isn't significant evidence proving that a high proportion of north-siders travel at all in comparison to south-siders, there is significant evidence showing that on average, the population of ETHS students who live in the north side of Evanston tend to travel farther than ETHS students who live on the south side of Evanston. Clearly from our data distribution, the mean was much larger from northside residents, but our data also showed that there were about the same number of people who reported that they didn't travel at all from each region. Our methods yielded different results, but it makes sense. Northsiders don't necessarily travel more than Southsiders, they just tend to travel farther on average than Southsiders. Traveling on short trips does not always cost a lot of money. But the long trips can be pricey, which still supports our original hypothesis that there is a wealth gap between the north and south sides of Evanston. This is also supported by the City of Evanston map, of which regions receive community block grants. As a result of our study, we think more funding should be given to the South Evanston to allow for improvements within the small community because that could bridge the gap in wealth and opportunity. The main limitations of our research were that we had a small sample size and that we didn't account for Evanston residents who were younger and older than ETHS students, so it's hard to make such large generalizations about an entire population of Evanston. If we could repeat the study, one thing that we would have done differently is to somehow incorporate the other region of Evanston, Skevinston. There are many students who attend ETHS that live in the area where Evanston and Skokie meet, and they were a whole portion of ETHS population that we simply did not account for. A couple of our data points collected include people who live in this area, but we chose to not include them in our study. This was acceptable because we were investigating the difference between North and South Evanston specifically, but it would have been nice to be able to include all regions that Evanston students reside in. Also, accounting for all ages in Evanston would have been beneficial. A large extension project that could be done would be to look into why certain groups form and what factors in people's decisions to live in one of the two regions. In order to explore these topics in a statistical fashion, questions for collecting data would have to be formulated. Possible questions that could be asked are, 1. Which region of Evanston do you consider to be safer, north or south? 2. Which region of Evanston do you consider to be nicer, north or south? And 3. Are you friends with more people who live in South Evanston or North Evanston? The proportion of individuals who answer for each region could then be looked into. We learned that in reality there could very well be a wealth gap between regions of Evanston. We also learned how different statistical tests on the same data can yield very different conclusions. Lastly, we learned about some of the very interesting places that our classmates traveled over spring break.